Good morning. In this video, I would like to explain about small sample test. Now let us see the concept of small sample test. So small sample test means if the sample size n is less than 30, then we call it as a small sample test. In the last video, we already discussed about large sample test. And we observed many problems in the large sample test, that as test for single mean, two mean, and single proportion, two proportion. But in the case of small sample test, if the sample size value n less than 30, then it is called a small sample test. So here in the small sample test, we are having the types of test as t-test for single mean, t-test for single mean, and t-test for two mean, and t-test for two mean, and the next one is we have f-test. So this test you are going to use for equality of population variances. Equality of population variances. And the last fourth one is the chi-square test. In the chi-square test we are having two types of tests again. That is what chi-square test for goodness of fit and chi-square test for independence of attributes. Chi-square test for goodness of fit and independence of attributes. These we are going to represent in terms of tabular forms. All these are small sample tests. So before going to the concept ones, we will check the 5 steps process of a small sample test that we already discussed in the large sample test. So to get a perfect clarification, we will check it one more time in the small sample test. Now let us see that for what purpose we are going to apply this small sample test. For example, the class, it consists of the class strength is 64. So before coming to the class, I am coming to the class for this semester first time. I am coming to this class first time. So I would like to check whether all these 64 students are good or not. So before coming to the class that I want to know, I would like to collect the data of all 64 members. So we are having 64 members, you are having the sample mean of the marks, and you are having the population, and we have the standard deviation. So any project works or whatever it may be, if you are having some data of the road accidents between from Hyderabad to Vijayawada, so we are having some data of 1 week we are facing with road accidents of 50 road accidents. We would like to check whether this data is right or wrong. So at the starting of the first year, we are trying to go to the project works. So in the project work, you collected the data. So before going to make an analysis, you would like to verify that data is right or wrong. Is there any significant difference in the given data or not? So if you are not clarifying anything about to check whether the data is right or wrong, if you go with a perfect analysis, so it's waste of time. So before going to make an analysis, you would like to conclude, you have to apply the process of testing of hypothesis, and we have to conclude that there is any significant difference in the given data. So now we are going to solve two types of problems. Whatever the data it may be, we would like to check whether this data is right or wrong. So now would like to conclude all these 64 students in the class are good or not. This is what I want to check. So I collected some data. Now my problem is all the students in the class are good or not. So this is a problem. So before going to solve this problem, so the first step I would like to check null hypothesis. The first step, the process is null hypothesis. So null hypothesis means a statement of no difference is called null hypothesis, and it is denoted by H naught. So it means H naught means there is no significant difference in the given data. There is no significant difference in the given data. It means that we are going to verify that there is no significant, that population mean is equal to the some specified mean mu naught. Or whatever the data we are having, we are going to check these students are good or not. It means 64, we are taking that H naught is 64 students. So now let us see the second step is alternative hypothesis. Alternative hypothesis means a statement against the null hypothesis. This is what we call it as an alternative hypothesis. So now in the alternative hypothesis, we are having 3 types of tests again. So that is what two-tile test, right-tile test, and left-tile test. So now it depends upon the given problem. We are going to verify the type of the test of whether it is an alternative is two-tile or right-tile or left-tile test. So now if our given question is We are going to check now all the students in the class are good or not. So we are taking the null hypothesis. So you are not having any information about the given data. You have to go through with the same question, and you are going to take all the students in the class are good. All the students are good. All the students are good. This is the way you are going to take with a null hypothesis. Alternative hypothesis, you are going to check whether there is any significant difference in the data. You collected some data of 64 members. This is the average mark, this is the mean value, and this is the standard deviation value. You are not having any information about the data. So we are going to check alternative is, we are going to define it with by H1. So H1 is, there is some significant difference in the given data. So we are going to write H1 is mu not equals to mu naught. It means in the given question, if they are asking to check is there any significant difference in the data, we are going to write our alternative hypothesis. H1 is, the type of the test is a two-tile test. It's a two-tile test. So each and every problem we are going to write only one test name, that is whether two-tile test or right-tile test or left-tile test only. So now if the given problem is, we are having, it is representing two types of the sample sizes, we are going to check the first sample size, that is two sample sizes are suppose of having n1 and n2. The first sample we are having some data of sample size x1 bar, the second sample is having some data of x2 bar, and we are having some population mean mu1 and you have some population mean mu2. And if you have some standard deviation values of sigma 1, you have the second sample of sigma 2. Now if your given question is while comparing these two samples, the first sample observations are in future or whatever it may be is more than the second sample observations, or the first sample observations are superior than the second observations, or we are having some height of the students, if you are going to compare, the height of the student is taller than, and is the data is going to increase. If these terms are there in the given problem, we are going to write our H1 is, mu greater than mu naught. So it means that the given problem contains, if it is more than, superior or taller than, the data is going to increase comparing to with other data. We are going to write H1 is mu greater than mu naught. So then the type of the test, it will be a right-tile test. The type of the test, it will be a right-tile test. Now let us see the next one. The third aspect is, you are going to finding out is there any significance difference between two types of sample of sizes. So in the same way, the first sample size is comparing to the second sample size is going to less than, or the observations are going to be inferior, or we are having the data is going to be decreased, or are you having any shorter than comparing to the before observations. If these terms are there in the given problem, in future it is going to be decreased, then you are going to write the value of H1 is mu less than mu naught. If it is mu less than mu naught, then the type of the test, it will be a left-tile test. Type of the test, it will be a left-tile test. So now the first step is, we have to set up the null hypothesis H0. It means that there is no significant difference in the given data. Alternative hypothesis, that is what we have. Second step, we are going to write H1, there is some significant difference in the given data. It means that while writing alternative hypothesis, to set up an alternative hypothesis, you have to decide the type of the test, whether it is a two-tile test or a right-tile test or left-tile test. This is more important step to fix the alternative hypothesis. If we did any mistake in the alternative hypothesis, obviously we are going with a wrong values, our data, it will be, we are going to give a wrong conclusion. So this is the most important step to set up our alternative hypothesis. Now let us see the third step is the level of significance. The level of significance. The level of significance, we are going to choose it as either 5% level of significance or 1% level of significance. And we are going to define the fourth step is test statistic. Fourth step is test statistic. It depends upon the problem. We are going to define in the small sample. Now we are having t test for single mean, t test for two mean, f and chi-square test. So we are going to write, generally we are going to write the value of formula. It depends upon, it means that the problem is based upon the problem, the formula is going to change. In the large sample test, we are writing the value, it will be of z form. Z is equals to x bar minus e of x bar by standard error of x bar. So this is procedure point of view, we are giving the formula, but problem to problem the formula it will be going to change. When it is a single mean, we are going to write the formula t equals to x bar minus mu by sigma by root n. So now the next step is a fifth step, we are going to write it a conclusion. So how to make a conclusion? The entire process we are going to do to make a conclusion whether this data is right or wrong. So how to make a conclusion means, if the calculated value of t is less than the table value of t, if the calculated value of t is less than the table value of t, we have to accept our h naught. We have to accept our h naught. Otherwise, it means that if the calculated value of t is greater than tabulated value of t, we have to reject our h naught. We have to reject our h naught. So, if the calculated value is less than the tabulated value of t, we have to accept our h naught. So now what is our h naught? What problem we are doing? All the students in the class are good. So if you are accepting means whatever the data we are collected, we are accepting the data is completely right, there is no significance in the difference in the data, and you are going to conclude all the students in the class are good. If any case, if calculated value is greater than the tabulated value of t, we have to reject our h naught. So it means that all the students in the class are not good. This is what we are going to define actually the alternative hypothesis. So this is the actual process of testing of a hypothesis, 5 steps. This you already studied in the large sample test. So for getting a better clarification, I am explaining it one more time. And here we are going to choosing the level of significance. This is fixed value. It is either at 5% level of significance or 1% level of significance. So now let us see here why you are choosing only 5% and 1% level of significance. We'll see here. In our normal life, we are having the types of errors. Actually, in the normal life, we have 4 types of errors. So the first one is accept h naught when it is true. The first error is accept h naught when it is true. Accept h naught when it is true. It means that if the given statement is true, you have to accept. For example, the sun rises in east. So it is a universal truth, you have to accept it. So there is no mistake in the given statement. So this is not, you are not call it as an error, it is a correct statement. So now, but the thing is, you are going to consider all these 4 statements I am explaining. Next, the second one is reject h naught when it is false. Reject h naught when it is false. It means that if the given statement is false, you have to reject. So the first 2 statements, these 2 statements, you call it as correct statements only. Now let us see what are the error statements here. So the error statement, let us see the third one. The error statement is reject h naught when it is true. Reject h naught when it is true. It means that if the given statement is true, sometimes you have to reject it. So for some benefits you are getting, so you have to some reject and accept. Every time in our day-to-day life we are not telling truths. So this is an error statement. Now let us see some more. Next error statement, the fourth error statement. What is the fourth error statement? Accept h naught. Accept h naught when it is false. It means that if the given statement is false, sometimes you have to accept that false statement. So these 2 only you are getting some benefits in your life. So these are, you are call it as an error statement. The first one, this is what we call it as a type 1 error. The first one we call it as type 1 error, and this type 1 error, it should be denoted by alpha. It should be denoted by alpha. The next, accept H0 when it is false. This is what we call it as type 2 error. This is what we call it as type 2 error, and it is denoted by beta. So now, in our day-to-day life, your objective is you have to reduce the types of errors. It means that the first two statements are called the correct statement. There is no mistake at all. So these two are correct statement. Our problem is, based on these error statement, we are getting the standard error to finding out, to check whether the data is right or wrong. Now, our objective is to reduce the error. So, that is the reason we are choosing that level of significance is either 5% or 1%. So, the meaning of this is 95 people out of 100, these are going with the correct statement. It means that they are always accepting H0 when it is true, they are always rejecting H0 when it is false. There is no problem at all these 95 people. So now the problem is they are going with the correct statement only. Now the problem is 5 people out of 100. 5 people out of 100, these are going with the wrong statements. So your objective is to reduce the error. So now in the same way, 1% means 99 people out of 100, these are going with the correct statement. Now our problem is 1 out of 100. 1 out of 100 is they are going to conclude reject H0 when it is true, accept H0 when it is false. Now our objective is to reduce the error. So in order to reduce the error, now the thing is we are going to choose the level of significance. That level of significance is either at 5% or 1% level of significance. So that is the reason we have to fix the level of significance is at either 5% or 1% level of significance. Now, one more thing we are going to define about in the conclusion. Suppose it means that small sample test, the definition we observed that is the sample size N less than 30. The test belongs to small sample test. While making a conclusion, we concluded the calculated value of t is less than the tabulated of t. We accept H0 for particular degrees of freedom. Degrees of freedom means the number of independent variates. The number of independent variates which make up the statistic. This is what we call it as degrees of freedom. So now, suppose we are having n is equals to 10 observations. We solve the problem of t-test for single mean or t-test for two mean. We are going to make a conclusion for a particular degrees of freedom as per the degrees of freedom as n value. So here the number of variables in the problem is n is equals to 10. So where we are going to finding out the value of n minus 1 df. It means that we have to follow 10 minus 1 is equals to 9 degrees of freedom at particular 5% or 1% level of significance. We have to make a table value and we are going to make a conclusion is that whether there is any significant difference in the data or there is no significant difference in the given data. So by this process we are solving all the problems in the small sample tests.